you start getting stretched. Because if you fall into the black hole feet first, your feet are closer to the center than your head is, and your feet are being pulled by the gravity stronger than your head. So you start to get stretched. as you get closer and closer to the center of the black hole, the stretching becomes stronger and stronger. And there is a term called spaghettification. It means you are turned into spaghetti. That's a technical term.
In the black hole's move for orbit.
Deep black holes move orbit. Yes, they do. The black holes which are at the center of the galaxies tend to be at the center because they have sunk in the gravitational pull of the galaxy. They have sunk to the center. So the large black holes tend to be stationary. But if something disturbs them, so the galaxies merge, and they get hit, then yes, they can move and they can orbit. So they obey all of the regular laws of physics, they obey all the regular laws of gravity, and they can all now.
A long time ago in my childhood, I heard about a term called white hole. That is, and then I heard about it is relative to the black hole, and I know maybe it's about the Einstein general relativity about time and space, and right now I don't understand the relationship
Between black holes and white holes.
white hole and about the time and space. Yeah.
So, let me first say what a white hole is. So, if you take the theory of general relativity, then the mathematics tells you that you can have things that look like black holes but are in reverse. Okay, things are coming out of them. They're very strange objects. These things where everything comes out of the black hole, nothing to the Earth. Now, that's what the mathematics tells you if you make very ideal assumptions when you're solving the equation. When you're solving equations, if you make very simple assumptions, you get that answer. We've never seen a white hole in the universe. We don't believe white holes exist. We've never seen one. So it seems to be that these simple assumptions you might make to get them from relativity don't actually occur. So, but they're interesting theoretical objects.
I think the next question of mine, I just asked about that. Teresa just mentioned about the Doppler, about the black hole, and that customers asked about the black hole when our moon or orbit. And what is the Doppler effect about between our Earth and black hole that we can observe? Yeah.
The black hole in the center of our galaxy, or any black holes?
In our galaxy.
Yeah. So the black hole in the center of our galaxy. The accretion disk is very faint, very, very faint. It seems that there's very little matter going in. So, in fact, we have not yet seen these Doppler effects from the gas around our own galaxy. The black hole at the center of the galaxy, the actual black hole itself is stationary. And we are moving orbit around our galaxy, so we are moving perpendicular to the line of sight. So So there's no dot Fisher there. So we haven't seen the dot Fisher from the gas.
As you mentioned in the very beginning, you say that if there is a very massive and dense object in a space, then the space will eventually be broken. And what I'm going to ask that, what do you mean by definition the space is broken? And do scientists really get the idea that how dense or massive an object should be to break the space?
So good question. So if you take the theory of general relativity and you have an object which is, has a certain mass and a certain density, then the theory tells you that object will collapse, and it will collapse until it becomes infinitely dense, infinitely small. And at that point, you can say that it has broken space-time. It has made a rip in space-time. Now, in fact, what this is probably telling you is that general relativity is wrong at that location. It is probably telling you that, we can never break the universe. What it's telling you is that when you get to these extreme conditions, these very, very extreme conditions, the laws of physics, which are applicable, go beyond general relativity. We need something new to really understand what happens there. So when you say that we sort of are torn space and time, what we really mean, we think what we really mean, is that we have pushed general relativity into a regime where it's not really applicable, where we need some new theory to there's two of the main theories of physics are quantum physics, quantum mechanics, and general relativity. And it is actually known as a serious problem that the two theories are not actually compatible with each other. You cannot make one theory that has both quantum mechanics and general relativity in them. So there are many physicists now who are trying to find a new theory that will encompass everything. And once we have that theory, I think then we can hopefully give you an answer. But right now we don't know what
In the film of the center of our galaxy, the stars, we say it will speed up when it gets closer to the center of our galaxy. But I only see the closest one speed up, and the other further one, why don't they speed up?
So they actually do, but it is much more subtle, much less obvious. So when you analyze the images in some detail, you actually find those stars are slightly speeding up. They're much further away, so the effects are less dramatic. It's that one star that has a very dramatic effect.
What may happen to a dying black hole?
What may happen to a dying black hole? Or, a black hole that dies? Or,
Yeah.
That's good. So we don't actually believe they die. They last basically forever. There's a little bit of a caveat to that. A little bit of an addition. Stephen Hawking has a prediction that black holes emit just disk, the actual black hole itself, emits a little bit of radiation. And over an enormous amount of time, so trillions and trillions and trillions of years, that can start to make the black hole shrink. But this happens on such long times that it is not relevant to our universe. So we don't believe black holes die. Once it's made, it lasts basically forever.
Why did you want to do research of black holes?
That's a good question. So when I was in university, I studied physics. I studied theoretical physics. And when I was doing my bachelor's degree, I studied physics. I became very interested in general relativity and the sort of extreme physics. So then when I started my PhD, I was naturally drawn to work on black holes because this is a place where you can study general relativity, but you can also see things and actually make measurements which are relevant to this. So I just became very interested in the theory. I think that's how I went.
恒星爆炸之后，质量为什么不会散开？
When a star explodes, how come the mass?
Great question. So, when a star explodes, it's actually quite a complicated thing. The core of the star, the central part of the star, actually implodes. It does this. And that releases energy, and then it's the outer parts of the star that explode. So they go different ways. The core shrinks and it implodes, and the outer part of the star explodes. So that gives you supernova. That gives you a supernova. So that's how you form the black hole. The black hole forms from the core, so it implodes, and then the rest of the star explodes.
This is the best question session I have ever had. Wonderful, wonderful question.
我也想要请个翻译。我有2个问题。第一个问题就是说，刚刚在讲那个气体会绕着那个黑洞旋转嘛？那我想问一下，就是气体在绕着黑洞旋转的时候，它有没有一个固定的方向？就是它是顺时针、逆时针这样？
The first question is when gas is open in the black hole, is there any direction? Whether it's counterclockwise or clockwise.
So it depends upon which direction the gas comes in from. So the gas has some origin. There may be a cloud of gas out here, and the direction of the disk just depends upon which direction the gas started out from. So if the black hole is like that, and the gas came in like this, then it would just go into orbit. So it depends upon where the gas came from.
Every black hole.
Every black hole is different.
然后我的第2个问题是，如果就是让一个无人的太空船，然后呢跑进去那黑洞里面，那它就会被吸进去嘛？那有没有可能，如果它抵抗得了那个 jet 的冲击力的话，有没有可能让它遇到 jet 然后再被喷出来？
为什么要无人？For an unmanned spacecraft. don't know. And I asked him why I'm mad.
Once you have fallen across the event horizon, there is no way out. You will fall. The actual jet doesn't come from the black hole. The jet comes from the inner parts of the accretion disk and from the surroundings of the black hole. Now, it's possible that if you were close to the black hole, you might then get thrown out by the jet. But once you cross over the event horizon, there is no escape.
好，对不起啊，我刚才忽略了这件事情，就是我们有答案我就没有翻译，我看大家用英文问就回答得很清楚，我不需要我准备要怎么问，所以很抱歉之前 I didn't translate the answer earlier。那你如果有听不懂啊，重点是要听懂，对不对？如果听不懂，其实就可以问刚刚应该问。所以我把它翻译一下，就是说那个箭仔其实是来自这个黑洞外面的跑进去，真正中间那个黑洞，如果你真的跨到你要回来的时间停下来的话，如果当你靠近的时候，我被吹走，然后就被吹走。至于说我刚刚开个玩笑说为什么要无人呢？其实他有回答，就是因为没有人会笨到要做那个改变。One question.
How can jets X-ray escape from the gravity effects of the black hole?
Good question. How can jets escape? So the jets are created by they're created close to the black hole, but not inside. So plus the jets are moving very, very fast. So some of these jets are moving at 99% the speed of light. So they're moving very close to the light. So even though they're created close to the black hole, they can still actually escape. Now, the details of how jets are actually formed is another one of these questions we don't really know the answer to. There's a lot of work, a lot of research right now on that question, on how the jets are really formed. But as long as they are formed outside of the event horizon, it's okay.
这个问题是问说，喷流为什么可以逃脱离开这个黑洞？那答案回答就是说，喷流是在世界地球外面的大气，而且溅得跑非常快，它的速度可以达到光速的99%。它只要在外面，它就最后一个重点就是说，详细啊，这个机制到底这个喷流是怎么产生的，其实是不知道。我们看到了这样的现象，所以还有很多工作，很多研究需要投入进去。
This probably make black holes on the Earth. I hear that they try to make to crash each other, and if someone say it may be make a black hole.
Can I first start? Let me translate the question. 我问的很，就是说有没有可能人工啊，在地球上可以制造出黑洞出来？
Yes, you're right. So at the LHC in CERN, the particle accelerator, one of the possibilities is that they could actually make very small black holes. They didn't. I don't think there's any evidence that they did make them. They would not be dangerous if we did make it because of two things. Firstly, I mentioned earlier that Stephen Hawking has these predictions that black holes would radiate some energy. Those small black holes he made would actually die very quickly. They would actually, within a fraction of a second, they would die because of the effects that Hawking discussed. Even if they didn't, they would be extremely small, and they would probably, most likely thing is that they would fall to the center of the Earth, but they would just sit there and they wouldn't do anything. They would be so small, they would be much smaller than an atom. And so they wouldn't be able to actually swallow anything because it's too small. It's smaller than an atom. So, but there's no evidence that they actually did make black holes.
回答就是之前有新闻啊，就是说那个超级对撞机啊，在欧洲那个加速器可以短暂的制造出一个小黑洞，然后大家就开始想的话，因为黑洞会合并啊，黑洞会吃别人啊，到最后会不会把我们整个地球给吃掉？那我就按你问说，很小的一水我们会不会淹死？这是两个完全不一样的东西。那刚刚解释说，那个对撞机制造出来是很小很小，比原子还要小的那种黑洞。那如果你了解黑洞，它是一种质能状态，刚刚讲的话，它其实它很快就挥发掉，或者它就掉进去，它不会任何东西作用嘛，掉到空中去，它就是一个小的爱不会吃别人，不会危害到危险。这个学生还是要考。OK， 如果还有的话，可以还有一点点时间可以留下来，可以跟讲者再继续问一些剩下的问题，或者是要照相。好，好，那今天到这边了啊。